And our last question is with the money. So this has one of the ugliest formulas with these numbers, but that's okay, right? As long as we pay attention to what's going on, don't let the numbers intimidate you. Here with our compound interest formula, we get A equals 1,000 times 1 plus 0.005 divided by 12 times 12 to the t. You can change the A and the t to x's and y's if that's more comfortable for you. That way it looks the same. And now we can simplify this or not. If you think about how much does it take for your money to double? So that's going to be, right, times 2, or, $2,000. So that's going to be our Y value. And so now, just as before, right, we put that in for our Y. Now we divide both sides by 1,000. And we get 2 equals 1 plus 5 thousandths divided by 12, all to the 12x. And so this, just as before, right? It's not pretty. So I'm gonna actually find that decimal approximation, right? This is our base. So base of the exponent, because right here, we'll change, right? This 12x is our exponent. So what we want to do, we need to take the logarithm of both sides, but the base of the logarithm needs to be that base. So you can put that in your calculator of 1 plus 0.005 divided by 12. And we get 2 equals 1.0030 zeros, and I'm just going to round it to 42, all to the 12x. So this becomes the base of our logarithm. The log base 1.00042 of 2 is the log, oh, I didn't use my green, of 1.00042 to the 12x. And so what this is saying is our log of 1.00042 of 2, right, equals 12x. This whole piece, right, this piece comes down in front, and then maybe I can write that. Do this. I'll clean that whole thing up. Times our log base 1 of, right, and then now, as we saw, again, these numbers are not as pretty, but this is still just 1, and so we're left with our log 1.00042 of 2 equals our 12x. And now same thing, divide both sides by 12, divide both sides by 12, no matter what it looks like, how ugly it looks. And this long base of 2, all divided by 12 equals x. So here we can, again, use the change of base formula to do that. This would be, and I'm just going to write it as 1/12 times the ln of 2 divided by the ln of 1.00042. You can put that in the calculator, or we're going to now see it in Desmos one more time. All right, so let's do those calculations first. We want 2, then the natural log, divided by 1.123042, then the natural log, equals, and then now we want to divide that by 12, because that was where we had, right, the 12x. And so we're about 137 and 0.56, a little bit more than 137 and a half months, I think, is going to be the time it takes for this to double, because our time here was in months. All right, so let's see how that looks in Desmos. All right, so here's our Desmos. Here's our graph, and you're like, wait, I don't see anything. And I want you to see how you can write it exactly how you see it, and right. And if you, why we don't see anything right here is because our window doesn't fit. It goes to 15 and we're in, this number is already at 1,000. So we really have to adjust our window. So we want to, let's see what happens if we go to 10,000. We don't need to go 10,000 on the X. Let's go to, sorry, I'm in the X value. Let's go to 300 on the X, and let's go to 10,000 on the Y. Oh, there, we started to see it. And so this is my exponential function, right? I didn't write it as the log yet, but this number is this number here. It's just not simplified. And so we can use this as, all right, how long, right? We started at $1,000. You can see my amount, or sorry, in this case, my T is my time, right? My X is my time. And so my amount is my Y. So from this graph, it's not that hard to see, right? How we made the window. We could scroll out and say, when does this graph equal 2,000? And we can see it's about, oh, right in there. You can even, as you saw before, say we want Y to be 2,000, and it gives you that intersection point right there. Oh, and it's a little bit off from what we had found in the change of base formula, but I think that little bit off is because of the rounding, since we had to round this logarithm to that, where this is not the, this is exactly that. So that's one way you can do it, if you like. Another way, if we look at, and maybe let's remind ourselves, right here, T is our time and Y is our money, right? So this is our, right, $2,000, and this is our right, how long it'll take to get there. And in this case, our time is measured in months. So it would be you know, almost 139 months. You can divide that by 12 to figure out how many years that is. Right, almost 11 and a half years. So if you did nothing, that's, you know, you would earn $1,000 over those almost 12 years. But that's not, that takes a long time just to get $1,000. So to see it, let's clear this now. If you want to see it in the logarithm, I'm going to turn that one off for a second, turn that one off. Let's look at this graph. So now things are different. X is now the money and Y is the time, because we were asking for how long it'll take. And so if we want our money, now we're going to have to, again, look all the way. We're going to need our X value to be 2,000. And you see our X value is only 500 here. So we can change this window to go out to maybe 2,100. And now we can get that 2,000. I don't know why that's numbers not correct. Sorry, I forgot our money isn't, we want it to be $2,000, right? But that's not, this X isn't exactly our money. So we defined this variable incorrectly, or I did, I apologize. What we want to see is this isn't our money, but this is kind of that rate. So we actually look here, let me zoom in. Oh, not that one. Right, we want to know when our money doubles. So we want our X value to be actually not 1,000 or not 2,000, but 2. And so we can go all the way up here to find when is x2 right here and that's the exact same number we just found, 137.558. And another, right, so this is going to be, we want x to be 2 for money to double. And then we can double check that by just typing it in, y equals the log base of 1.000442. And then we're going to have that of 2. And then we have that whole thing divided by 12. Oh, and I'll clear my, and then we get that exact number here. Oh, and you can see now those two intersections. So for me, clearly, I think typing it into Desmos is the easiest. Let Desmos be your calculator. But I also want to show you how you can read it from the graphs of either the exponential or the log function. You can read it either way.